Welcome to Energy Talks, a regular podcast series with expert discussions on power system testing topics. My name is Scott Williams from the podcast team at Omicron, and I will be your host. One of my favorite episodes to do on Energy Talks is when I have the chance to talk with engineers in the field who share their knowledge and experiences with power system testing. In this episode, we are going to talk about protection testing, which is an important aspect of ensuring the reliability of power systems. I'm going to speak with a protection testing expert in India who is really passionate about what he does, so much so that he has built his career and company around it. So without further delay, let me introduce Saravanan Balamuragan. He is a protection testing expert at Minitrol Power Systems in Southeast India. Saravanan actually wrote to us at Energy Talks, asking to join us as a guest to share his knowledge and experiences. Hi, Saravanan. A very warm welcome to Energy Talks.
Hi, Scott. Good to be here. Thank you for having me over here today.
Well, thank you again for being here with us. Saravanan, to start, could you tell us briefly about your company?
We are Minitrol Power Systems, which is a Tamil word, which roughly translates to electric power. We are a 4-year-old startup and a protection consultant wherein we design, analyze, test, and commission various power system protection elements such as protection relays and bay control units. We also conduct training programs and carry out research and development at our company on different power system domains. We aim to help our customers with the digital transformation by providing our expert services using state-of-the-art equipment and software.
Okay, where is your company located exactly?
So we are based out of Chennai, India, that is on the southeast of the mainland. Yeah.
Okay, and what are your responsibilities at the company?
I am the founder and CEO of the company. So, considering that this was a startup, I also had to travel to multiple locations, talk to clients, take up projects, and execute them. I was also a solo founder, which meant that I actually had to do the testing part of the projects as well. Now, I have
Okay.
expanded the company to 3 divisions, that is, design and analysis, testing and commissioning, and training and research.
Okay. What is your background in the power industry?
I am what you would call as a second generation electrical engineer. My dad also started his career as a protection testing engineer. So I have been exposed to this field since my childhood. So even as a 10-year-old kid, I have visited power plants and substations. Once I completed my undergraduate program in electrical engineering, I started a transformer servicing company from which I pulled out of as I felt that I was not being challenged enough. And my dad kind of pushed me towards relay testing. So I directly approached Omicron Delhi for their training program, which was a truly life changing experience. Once I had a certain level of experience in relay testing, I moved abroad to Dubai. And I noticed that since I was trained professionally by Omicron, I could guide people who have more than 3 to 5 experience. And this motivated me to go deeper into power systems. So I completed my master's in power systems, started my company, and doing PhD research as well right now.
Okay. Who are your customers? In which industries are they and where are they located?
So our customers range from power plants, renewable energy sector, industries, utilities. So basically, the way I would say is anyone who has a power system asset which is being protected by a set of protection relays,
Hmm.
they would be a part of our customers. So we have government utilities. We have a lot of private industries, huge, large scale industries, steel plants. So anyone with a power system asset would be a prospective customer for us.
Okay. So you mentioned your background in protection testing, quite a long and experienced background. Why is protection testing emphasized at your company?
So the protection relays or IEDs or intelligent electronic devices, they play a very central role in power systems. So a key point to note that a protection relay rarely operates, means it only operates for faults and system disturbances. So over its entire lifetime, it is actually not supposed to operate. But when it is supposed to operate, it needs to do so with zero tolerance in a span of few milliseconds to avoid any major events or failures. Now, with high penetration of IEC 61850 and digital substations, the importance of these IEDs have increased manifold. So they are the single source of data and equipment for system status, control and protection signals, and alarms. This means that the main characteristics of the protection system, that is your selectivity, sensitivity, stability, speed, and more importantly, reliability, needs to be checked frequently. So this results or the results that we have done gathered after the testing ensures that the relay will operate when it is required to operate and not operate for faults outside its protection zone.
Why are these measurements important for your customers?
So one of the main reasons why customers would want to do protection relay testing is they want to ensure that the settings that they keep and the configuration of the protection relays are specific to their own application. So when we go for protection relay testing, we not only check the configuration, but it is also important for us to check what is the setting values that we use and whether the equipment which is being protected can be protected using that particular configuration and setting values.
Okay. On what types of equipment are you performing these tests?
So for protection relay testing, we use the secondary injection test kit. So the reason why it is called secondary injection test kit is because we inject on the secondary side of the instrument transformers towards the IEDs or the relays. So in our company, we mainly use the Omicron CMC 356, which is one of my dream pieces of hardware since I saw it as a kid. Now, it the main reason why we go for Omicron is that it is one of the most versatile equipment that I have handled till now. It gives me the flexibility that I need along with the freedom to make simple as well as very complicated testing as well.
Okay. What is important to consider when performing protection testing?
So when we are performing protection testing, like I already mentioned, the first thing that we need to take into consideration is the right equipment for the right job. So sometimes we have simple tests for which we do not need very complicated equipment. And for complicated tests, we cannot use simple equipment efficiently. So we need to ensure that the equipment is flexible for our specific needs and it is also versatile enough so that I can automate a lot of process that I usually do recurringly. And
Hmm.
obviously, we need to make sure that we have taken the necessary safety precaution, such as the protection relay and the system under test has been isolated in case we are doing any online test. And once all the necessary checks are completed, we need to verify the connections physically before we actually inject any parameters. So, on a personal level, for complicated testing, I would want sophisticated software which can give me certain degrees of freedom and
Hmm.
flexibility, along with very simple automation for ease of performing the test based on my own individual style.
Okay. How often do you perform these measurements for customers?
So there are various stages of relay testing. So first it is at a factory level where we test the relays along with the control panels at the factory before it is shipped. Now this is done to ensure that all the wiring is perfect and the relay is healthy. A similar test is also done at the site level for checking for any damages during transportation. The next step comes around commissioning test. Now this is very crucial because they are exhaustive and we need to ensure every single aspect of the relay, all the way from powering up the relay to functional and signaling checks. Now once the station or plant is commissioned, we perform maintenance checks every year based on the relay healthiness and operation. Now in case any changes needs to be done by the or any changes needs to be done to the relay settings and to the configuration, we retest the relay to verify the same. Also, if a relay maloperates or fails to operate, we recheck the relay thoroughly as to analyze why it happened. Sometimes it can be something as simple as a wiring mistake or something complex as a relay hardware failure.
Okay. Now, if I may ask you, you recently had an emergency at a substation. Was that related to protection relays?
Yes, it was actually very much related to protection relays. So, one of the feeders that we protect that comes under our maintenance strategy was that it was a 3 kilometer cable for which we were right now the customer has recommended only overcurrent protection. So, what as a consultant we have recommended to them was to use cable differential protection. Now, the emergency that came up was the relay has tripped, that is, the overcurrent protection has tripped, and the problem was they couldn't identify the location of the actual fault. So,
Hmm.
we had a set of differential relays, we installed the differential relays, and these differential relays had a backup distance protection as well. So, now what they wanted was they wanted us to prove that we can not only detect faults, but we can also pinpoint the location of the faults. Now we know that a protection relay can do it, but in order to prove it to the customer, what we had to do was we had to do an end-to-end test. We connected Omicron on both ends of the substations, both ends of the cable, and we proposed to use simulation-based testing. And in the end, we had to inject faults in multiple location to prove that the fault locator, which is present inside the IED, is working correctly. And because we had our Omicron CMC, we were able to do it within a very short period of time.
Okay. What are some of the key things that you have learned about protection testing over the years?
So the one thing that I always tell people is that there is an art to design of protection system. Now the same thing applies to protection testing as well, as there is an art and a skill of actually doing the protection testing. Now, it may seem simple to an outsider because what they see us protection engineers doing is we are injecting random parameters and random values of currents and voltages. But it is more about a planned sequence of activities along with the perfect combination of hardware and software operated by a knowledgeable expert engineer. And the ability to work safely and correctly under a lot of pressure comes with the job. This means that you need to have a sufficient knowledge of both the protection system as well as optimal equipment usage. And this would go a long way in helping you in doing protection testing in the best possible way.
Okay. How do you analyze the data and present the data results?
Once we have completed the testing, there are two ways of getting the test reports. So the first one is more manual in nature, wherein you note down the parameter values along with your timing results as you perform the testing. And the next and a easier way is by getting the results directly from the software itself. Now the Omicron's Quick CMC or the Test Universe module allows me to generate reports directly from the software, and if I'm using any automated functions like the OCC files, I could have a very flexible and exhaustive reports ready for me the moment I have completed the testing. Now, these reports are submitted to the end clients, and generally, the way analysis is done is by comparing between expected versus the actual results of your testing. And in case of any specific failures or faults that we have tested, we usually collect the disturbance records and the events from the relay after the testing has been completed.
Okay. Well, you had mentioned before a situation you had at a substation. Do you have any other unique experience to share about protection testing or power system testing in general?
Yeah, I actually have two examples for it. So, one example which actually shows when I talk about the flexibility of the Omicron CMC was when the client requested me to show the operation of the circuit breaker along with the protection relay. Now, this may seem very simple, but the key thing that he wanted the circuit breaker timing as well. Now, like I already mentioned, the CMC is a secondary injection test kit, which means it can inject current and voltages to the relay, but it is also a very sophisticated and advanced timer. So I created a very short test plan which involved wiring all the three phases of the circuit breaker contacts as feedback to the CMC along with the feedback from the relay. So when the relay tripped, I was able to get the trip time of the relay as well as the individual trip time of each phase of the circuit breaker. Meaning, we ended up doing breaker timing test along with relay testing using a single piece of equipment. To point out, there was another very interesting example was we were testing distance protection relays. Now, distance protection relays, like all people know, it is very complicated. And the fact that we were testing old distance relays, it made it even more complicated. So Omicron, with its protection test library, that is the PTL, it came to our help. So, with the help of PTL, we were able to download the settings from the relay. We were able to export the settings from the relay software and import it into the Omicron software. And we were able to test a single distance protection relay, including its communication verification, auto reclosure checks, and all the functional checks within the same day. Now, the fun thing about this project was when we were doing the testing, the temperature was around 2 degrees centigrade. And
Oh,
as per Indian standards, this is a very low temperature to work with. So,
interesting. Well, I understand that your company is also involved with renewable energy, such as wind and solar power. What types of considerations are necessary in this area when performing protection testing?
so when it comes to renewable energy, the first is it's widespread in nature. So, if you consider a solar power plant, the protection relays are spread out throughout the entire power plant in case of a decentralized protection scheme. Now, in this case, we will or we must have to do the testing outdoors. So, which means that I have to ensure that my kit and my equipment is suitable for working outdoors. And
Hmm.
second thing is, I need to have a flexibility in supply options itself. So, in some cases, if there is no power supply available, especially during commissioning, what we usually do is we can power up the relay and the protection panel using the Omicron CMC itself.
Hmm.
But other than that, the testing of the protection relays would be the same. But more importantly, the flexibility that the CMC offers is unmatched when it comes to testing over a widespread physical geographical area.
Okay, thank you. Now, how do you see protection testing in the future?
So, right now, what we call as testing, we are essentially checking the relay settings and configurations. So, what we do is we take a protection element, and based on the functioning principle of the protection element, we check and we do timing tests like pickup and drop off checks. We do timing test to see the trip times. And for more advanced relays, we may need to test multiple protection functions within the same IED. Now,
Hmm.
this is what we refer as functional testing. So, in this, we only play with parametric values of voltage, current, phase angle, and frequency. The reason this is still being used is that it is pretty much straightforward. But from a technical perspective, this is not what an actual fault would look like, right? So an actual
Hmm.
fault will not start from zero and suddenly give you a weight of a current of 1 amps or 10 amps, right? So that is why I see that with Omicron's new software, I see that the future is what we would call as system based protection testing. Now, rather than playing with the parameters, we define the system under test along with the respective equipment such as transmission line, transformers, your instrument transformer, source, load, etc. Now, once
Hmm.
this is done, we should be able to simulate a sequence of event such as a breaker opening, fault clearing, a fault occurring at say 50% of line length. Now, once the simulation is done, we can also choose what should be the expected response from the relay. And we should be able to change all the parameters such as line length, the fault resistance, and we should be directly injecting the waveforms generated from the relay sim test into the protection relay. Now, this means that I do not need to worry about individual manufacturers' settings, individual manufacturers' algorithms. All I have done is now measure the relay response based on a particular event and verify its operation. Now, this saves a lot of time and it decreases the complexity of testing. But more importantly, we have injected parameters that are close to the actual power system events. So we can directly prove the reliability of the protection system to the end user.
Interesting. Okay. Now, you had mentioned some of the things you're already doing with it. What are some of the ways your company is preparing for these future trends?
So, one of the ways that we see our engineers is that they need to be prepared for any kind of a possible event that could happen within your power systems. Now, our engineers are expected to be a benchmark for relay testing. Now, this is the prime focus of our internal training programs, and we encourage in our engineers to participate in webinars, conferences, and even write technical articles. As a company, we are promoting and educating the end users with state of the art solutions and technologies so that they could see that their problems could be solved faster and more efficiently. So, like I already mentioned, we have a research division as well, in which our testing engineers play a very important role, which means that they are
Hmm.
not only getting trained about the present, but are also future ready.
Very good. Now, going back to your experience in and passion for protection testing, I understand that you have a blog on your website called the Protection Engineer's Diary, where you write about protection testing topics. Could you tell us a little about that?
Sure, Scott. So, I just wanted to have a way of expressing the feel I have while discussing about protection systems. Now, my wife says that all the blog titles are kind of romantic, but that is kind of the way I feel towards protection systems. But more importantly, I always feel that engineers lose a touch with their creative side after a few years in the field. It makes them a bit more mechanical in nature. But
Hmm.
to be in touch with the reason why you became an electrical engineer will definitely make one satisfied with their job as well as make them a better engineer. So this was the thought process that went behind the whole blog that I'm going writing.
Very good. Now, you mentioned before that your company also offers professional courses in your training academy. Could you describe those?
Sure. So electrical engineering is in the brink of a huge digital revolution with a lot more of private sector participation and massive decarbonization of the grid. Now, this sector will require thousands of first class professionals who have prior experience in running consumer centric businesses. But they also need to be trained in technology related fields like analytics, cybersecurity, even statistics. So, we want to play our part by educating budding engineers in this core field of electrical engineering. Through this, we also want to spread awareness that this domain is interdisciplinary by nature, and we need all the best minds we can get for an electrifying futures. Now, our courses are tuned with a hands-on approach and with a motivation from Omicron, I would say. We are also in the process of setting up a remote lab for online learning of protection testing as well.
Well, Sarah Vanan, thank you very much for sharing your knowledge and experiences with protection testing in this episode of Energy Talks.
Thank you so much for having me over here, Scott. It has always been a dream to be connected with a company like Omicron, which has a history of innovation and continuous knowledge sharing. Thank you again.
Well, we certainly appreciate you. Thank you again, and I wish you much success to you and your company. And a big thank you to our audience for listening to this episode of Energy Talks. We always welcome your questions and feedback. Also, if you would like to be a guest on Energy Talks to share your knowledge and experiences with power system testing, let us know. Simply send us an email to podcast@omicronenergy.com. Omicron has several years of experience in power system testing. Protection testing is certainly an important aspect of this. So, to find the matching testing solution for your application, be sure to visit our website at omicronenergy.com. Please join us to listen to the next episode of Energy Talks. Goodbye for now, everyone.